Hi guys, Adrien Lambert here, welcome back on my channel. Today is a bit special because we are celebrating the 2 years anniversary of the AL tools and the release of the version 6. So for those who have no idea what those are, well, that's fair. This is basically a set of environment tools designed in Houdini to help facilitate terrain export, terrain modeling, scattering of vegetation, and all kind of things, right? So today's video is gonna be very much about this tool specifically and provide some sort of documentation or some kind of help for you to use them. Now, since I released those tools, you guys have been insanely productive and I've been very impressed by the work you send me. So I'm very happy to share all the work that you have been up to. So without further ado, let's check this out right now. I couldn't be more proud of you guys. That's very insane work. So thanks everyone for contributing in this reel. And if you haven't done so, please send me your work because I will post this customer reel very soon on this YouTube channel. All right, so if you want to be in there, grab my contacts at the end of the video or in description and send me a link. So yeah, today's gonna be about AL tools and you can treat this video as a kind of documentation. I'm gonna add some timecode in description. So yeah, you can use that if you have anything that you want to spot, you want to check the scattering of that thing. Well, that's very up to you. So what I actually did to improve this tool, I worked on a little scene. Might look pretty simple, right? It's just a forest path with a deer or stag. And well, what's happening is that it was actually a pretty interesting exercise to push the limits of this tool because there are so many elements that's happening in there. Actually, if we break down things, you can't do an environment where you're like, oh, I'm just gonna do a forest, I'm gonna grab a ground, put a megascan in there, sprinkle some trees and call it a day. No, that's not how it works. So what's happening, we indeed have a ground layer on which I'm adding some structures, some structural elements like, well, the character and the puddles, these kind of things. And only then I'm starting to add some dead leaves. So I'm using the scattering system for that. And we can notice that I also dress the water. I'm actually scattering some dead leaves in there and they are all flat to kind of suggest that they are floating on this water, right? And that's a mistake that a lot of juniors do when it comes to water dressing. Well, there's just no dressing. Usually they just put a water plane and call it a day, when actually there can be a lot of things happening with water. There can be some high grass, there can be some branches floating and all kind of crap, right? So that's the kind of thing you want to consider when making an environment in film. Yeah, at this point I can start putting some green, like grass, clovers, that kind of good stuff, make some green pop. So that's pretty nice. And after that, I'm basically adding some ivy because ivy is life. And I already did a video about ivy and how I'm generating that. So you can definitely check out this link. It's basically using a plugin created by Mark Chevry. Also adding more details in the description if you're interested. So yeah, check it out. Only after that, I'm ready to add some trees. And even the trees, I usually like to treat them as some kind of independent ecosystem, right? Meaning that most of the time you would take a tree and you would find some moss on it, you would find ivy, you would find mushroom, maybe this kind of stuff, right? So that's a first pass of dressing that I'm doing on those trees, and then I'm scattering them. So yeah, at least trees that you know that you're gonna see potentially the trunk, right? If it's an aerial view of like a big forest, there's no point of doing that, of course. But if the trees are pretty close to the camera, consider doing some set dressing on those trees, right? Yeah, there is that. And only then I'm refining the material, the lighting, the fog, kind of stuff. Little fun exercise, and also taught me how to groom for this stag. So I don't know, if something that interests you, I can give my 2 cents on groom. So what is sure though is that I will share different videos about the creation of this scene, from the terrain modeling to creating USD in Solaris to create a kind of gallery of assets, right? And how to lay out those assets, how to light, how to use material X to create material, that kind of good stuff. So yeah, that's coming. So if you don't want to miss that, please subscribe and click the bell button to not miss these videos. Promise, it's exciting. Now, today's video is going to be about the version 6. And I must do a quick disclaimer here. I have been doing so many changes in the way AdvancedScatter work that it is not retrocompatible with the past or current project. So that's kind of a bummer, I know, but there are so many cool new things that it is worth considering recreating your node if you are currently working on a scene with it. If you have like a couple of AdvancedScatter nodes in there, maybe consider recreating them using the latest version. Otherwise, just don't upgrade it yet and wait the end of your project. All right, so what are those changes all about? We're gonna see that right now. All right, let's get started. What I want to show you first is a very simple scene as an example, because it will allow you to kind of see what are the big idea behind this AdvancedScatter and what are the new features. So this scene is fairly simple, right? It's just like a kind of sphere with kind of a path with some trees and stuff. So we'll see how we can do that. And the first thing I want to show you is what do we need to get started. And what you need might be some trees or any element that you want to scatter. So I'm basically making this kind of library ready that I group under this network box called library. So the way I usually proceed, I have on one side the high-res geometry, which is, well, the model that I downloaded from internet, applying my shaders and whatnot, and happy with that. I'm moving on to creating a proxy of this guy. To create a proxy, well, this is basically the low-res version of the same model. And the way I'm doing that is by scattering a bunch of points on the leaves or the needles or whatever it is that is taking the most of the polygons. So if I'm looking back at what we have here, we have this tree with a bunch of leaves and stuff, and I'm splitting the geometry with the split node and using this symbol to get all the groups that have this needle string in the name. So basically, this will extract this needle group right here and put it aside. So on one hand, I have this geometry with all the branches, the trunk, and on the other hand, I basically have this geometry of leaves. So by doing that, I'm starting by creating a scatter, as you can see, and VDB from particle allow me to kind of convert these particles into a volume. It's super blobby, so that's kind of not what I want. So I'm just like using this VDB smooth to get a much more simplified shape. I use also a VDB reshape to actually erode this volume, because compared to before, if I'm looking back at my geometry, we had a much thinner kind of look. Like, yeah, without it, it looks very inflated. So we kind of want to conserve the silhouette of the trees, right? So it's important to spend a bit of time, make sure that the silhouette of your proxy fit your high-res. And then I'm converting that back to polygon. So this convert VDB is pretty nifty because you can use adaptivity to actually reduce the amount of polygon. And that's pretty fast to reduce, okay? So that's the first thing. On the other side of this split, what I had was the trunk and all the branches, right? But I don't actually need all these branches in my proxies. That's way overkill. So I'm using this labs tool, delete small parts, and delete small parts is great, because then I can use this extract largest piece that basically extract this trunk, and that's all I need really. I'm using a polyfill just to make sure that this is a closed geometry, because when you wanna then convert that into a VDB, you need a closed geometry. So I'm merging everything, and only then I am converting everything into a VDB again, just to kind of fuse the trunk and the foliage together, right? So converting back to polygons, and now we have one single mesh that should be pretty low res, right? And in my taste, it's not even low res enough. So right now we have 13K points. That's still a lot to me. I usually don't spend more than 1K polygon for my low res, right? So what I do is I'm adding a poly reduced after that to get even less polygons. So now I'm more like at 427 points, which is pretty fair to me. And could even go lower, but yeah, we see the trunk's getting a bit too funky. So yeah, something like that, I'm pretty happy. And finally, delete small part again to make sure we are getting rid of the minor kind of artifact that might still be in there. So that's the way I'm basically creating a proxy, and that will help a lot when it comes to scattering and have a proper display. Okay, so also I imported a bunch of rocks from the Megascans, and that's also useful to have. They are fairly low res, so that should be perfect for what we need to do here. And at this point, we are ready to prepare our surface. So when it comes to environment, you want a library of elements like these, rocks, trees, whatever you want. And on the other side, you need a terrain or something. In this case, I went for like this kind of sphere look. That's kind of a mini planet, right? And yeah, I think that's kind of a fun exercise in this case, because I will show you how you can control orientations based on normal, etc. So let's see. How is this done? First, it's pretty simple, right? I'm just gonna break this down real quick. We have a sphere, adding some UVs real quick, but that's really not important. Attribute paint, and that's what I'm using to actually paint my river. So when I press enter, I can always edit things. And if I want to add like a river, I can start painting stuff right here. Whoop. And yeah, that should be a new branch of my river right there. Poof. So yeah, fun stuff. From that, we are basically creating an attribute mask that is containing this data, what we just painted. What I'm just doing here is I'm mixing that with a noise using my AL mask builder. So if you don't have it, that's okay. You can still do that in a point VOP or Vex, whatever you need. It's should be pretty straightforward. Finally, I'm blurring this mask a little bit. Well, actually quite a lot, I guess, with this blurring iteration. And finally, I'm mixing two inputs, which is the original sphere that contained the mask attribute, and on the other end, a slightly kind of, yeah, slightly reduced version of this sphere using a peak. And now when I mix both inputs, I can get this, this kind of shape with the river that is carving our sphere, right? So yeah, that's the main concept. So very simple stuff. Then subdividing this sphere a little bit more to get some extra detail when I'm adding some mountains up. So mountains up, I'm using that to add some bit of displacement and stuff. As you can see, it's also inflating this kind of river, so that's not great. Adding some more noise, like high frequency stuff in here. And finally, I'm mixing both inputs again, but just to preserve what we had in the river. So that's pretty nice, because now I have my river a little bit less noisy, but fairly noisy. So yeah, I can always adjust my mask if I need to kind of reveal more or less of this noise, right? Based on the mask that we created. So moving on, I'm finally doing the scattering part. So this is the node I was talking about. And the first thing, if you use this node before, is that you should notice it has 3 inputs now. Well, the first one has always been for the surface. You can use the plugged surface as an input for your scattering. So in here, you see that you have this input, and otherwise, if you don't want to use it, you can always specify a custom geometry if you want to create your scattering. So I don't know what this geo1 is in this case, but yeah, you can specify a custom geometry right there. Okay, in my case, I'm going to keep it in this input A. The second input and the third one is only for transferring attribute or creating mask based on an object. So we'll see that later. So let's rebuild this little setup from scratch. We'll drop a AdvancedScatter, because the way it works now is fairly different. I was saying there are a lot of things that change compared to the past version. So in here we can control the density as usual. And yeah, that's still a bit too much, so I'm gonna reduce that. We can, of course, relax the positions of those, and based on the scale of your scene, you may wanna relax it more or less. So that will keep them fairly distant from each other's and avoid intersection. So yeah, that's the first thing, right? But so far it's just points. One thing that is changed is as soon as you press enter in the viewport, or if you click this show handle, now you see that you can visualize the surface. So that's a new addition to make sure that the geometry doesn't render and things. And also note that you can control the display of this based on the right click on the mouse. So if I don't want to see the surface, you can totally say I don't want to see it at all, even when you press enter. So I'm happy to have it. Let's actually hide the grid. And what can we do from that? As I was saying, that could be a scatter of trees, right? So we don't want it to be affected in these areas, which is the river. So we have different kind of scattering solutions, right? Based on height, etc. And you can actually, if you want to get rid of some tabs that might confuse you, if you know that you're not going to use curvature, occlusion, I don't know, map, if you don't need object, well, you can basically choose what you want to show in there. So that's a new thing in this version 6. So you have this preference tab right here that you can collapse or not. And yeah, really control what you want to show in there. In that case, I'm happy to use one of these attribute 1 or 2, to call a custom attribute. So we can enable it and say, okay, in my input 1, I want to use the attribute called mask. So that's the mask that we painted earlier. And what we can see is that in the white area, it's going to create some points. Where it's black, it's not going to create them. So that's the density, right? And you can use this curve to basically remap this density. So yeah, if we want something more or less like that, we can totally do it. But in that case, I want my trees to be on the black area. So we can basically invert those values and say the min would be 100% and the max 0. So that's gonna force to change a little bit this ramp and probably contrast it more like that, or like probably more like that, right? Yes. So I don't want to see any points in the river, so I'm happy with something like that. So pretty fun stuff, right? But as you can see so far, we don't have any geometry assigned on this point. That's kind of a problem, right? What you want to do in that case is go to Object to Scatter. What you can see is that if you scroll down, you have this Assign Object tab in which you can assign objects. So I'm gonna go in there and grab my 3A HQ for high res. As soon as we are plugging that, nothing happens. Well, fair enough, because you have 2 modes when it comes to scatter. You can by default use the instance, which means that if this node is based in an instance context, it will use the instance attribute to attach a geometry. And these attributes, if you use another render engine, might be different. So I actually exposed it, and if you need to rename it to something like instance attribute, or I don't know what this can be in Arnold or any other engine, you can customize the attribute string. So yeah, that's one important change. And this thing right here is pretty new too, the way to control the assignment of the objects. So as you can see so far, there's nothing attached. We can say attach geometry if we want to see the trees. And okay, the first thing that strikes me is that they are way too big, right? And we can go in transform for that to adapt the overall scale. So uniform scale, we might want to reduce that 0.1 or 0.2, 1.4 or 1.5. Okay. So yeah, that's pretty nice. But at the same time, you see, we still see a lot of bugs, right? So if you want to change the display, if you right click, you can change to a box. And this would be using the bounding box of your object to scatter. You can use pyramid, you can use point cloud, you can use a custom geo. And note that these are also available in the display tab right here. And that's where you can control the look, the color of the different instance that you are adding into your system. So what we want to do here is probably use the low res geometry that we created. So I can basically use this custom geo, or go in there and say custom geo. And what it's saying is that an extra slot for custom object has been added in object to scatter tab. So if we look in there, we see that we have this low res geometry that has been added. So let's actually assign a geometry in there. So let's grab this low res geometry. And as soon as we have that, you see that the display is much cleaner, right? We can see everything without any weird bounding box, and that's the benefit of creating a proxy. So it's much nicer this way. We can of course add more trees by clicking. Well, let's add 3, 4 of those, okay? I'm gonna quickly add the 3B with its low res version. I'm gonna add the 3C low res. We want the 3D and the 3D low res. So they haven't been updated. As you can see, it's still kind of not showing up, mostly because we need an update. Let's change the seed or something and it will show up. So now we have different objects in our scatter. Much nicer, right? So let's say we want to show less of this D variant. We can use the probability slider right here to decrease the amount of time this tree will show up. So 17%, meaning there's 17% chance that this tree show up. If you reduce to 0, well, it won't show up at all. And same for the others, you can control like that the amount of time that you want to see an object. So that's pretty nice. And in that way, it's very different from how it was set up in the past version. You can also notice that you have some extra control that you can use, let's say the scale and the time offset. So it's going to add an extra slider for each object. This way you can control the scale of everything independently. Let's say I want to scale this specific guy to 120%. You can totally do that. If I want to reduce this one to 80% for some reason, well, sure, you can. And same with time offset. So what's great with time offset is that if you have an animated cache, okay, with some kind of wind animation or any kind of dynamics cached, you can use this time offset to actually add the same objects. In that case, I could add 3D low res, move the time offset to 50 or 75 frame. I must point out that this is based on frame. And just by offsetting, it would give the illusion that you have more trees than what you have, because you are offsetting the cache and therefore creating breakup. So in that way, it's, I feel, much more useful to have this time offset and all this thing right here. It should be much more flexible for you to control the different instance. And if you need any other thing, we can totally try to implement that in here. And yeah, that should be pretty fun. Now, when it comes to orientation, I want to show you something that's been changed. As you can see, everything is oriented following the normal direction, right? So in that case, since it's pretty noisy, we are getting quite a lot of chaos. And you can actually change that in transform. And you can control, obviously, the orientation if you want things to point down, point up. So that's a new addition, because before you could just point up or based on the normal. Now you have all the in-between kind of state that you can use to create your custom orientation. So that's one major change, actually. And note that you have now smooth normal. So in that case, it's pretty nice because you can use that to unify the direction of the normal. So since it's very noisy, everything's looking in very weird direction, so that's not great, right? But as soon as we increase that, let's say to 100%, you start to have trees that follows a much nicer and much cleaner direction. So that's one big change too. And yeah, of course, you can always combine that with the up and down, etc. So there is, of course, other modes. There is the up, but it's not actually useful. I mean, you can totally point that to 1 and you would get the exact same result. You also have sun, which is very new. And what you can do with that is that you can assign a custom object to actually target the orientation of your objects. So let's say I'm creating a sphere and I'm gonna move this guy up. Let's assign this sphere in there. And as you can see, as soon as I move this sphere, my tree should follow it. Ooh. So yeah, that's a way that you can customize the direction of your trees, mostly because trees, they are growing following the direction of the sun, right? When it's at its brightest state. So that's one way you can actually customize the orientation of trees. I'm saying trees, but can be anything really. And of course, you have the sun weight that will switch between the up vector and the sun direction. So if you go back toward 0, it should be much straighter. So yeah, just one thing to keep in mind, you have different orientation control options now. So yeah, fun stuff. In that case, leaving it to something like 0, I'm happy with that for this kind of weird planet thing. And yeah, well, in here, not much change. You can control uniform scale. Ooh, I actually also added a translate function that we didn't have before. So now you should be able to control the translate based on the normal direction. So -50, that would basically push them in, and 50 would push them out. And of course, you can randomize this translate as well if you want to get some interesting variation too. So -20, 20. You can change the seed. And if you don't want this to follow the normal direction, you can assign the world. So maybe in some situation you want the world coordinate, not the local ones. So yeah, I thought it was interesting to expose this parameter in case it's useful. So yeah, pretty nice stuff. I think in general, what you want to randomize the most is the orientation. By default, they all have the value of -360 to 360. And well, some bit of rotation to kind of randomize the X and Z. So yeah, fun stuff. Same for the scale. You have this kind of features, and the uniform scale as well is exactly following the same kind of principle where you can randomize the uniform scale. One thing I haven't talked about yet is this enable step. That is very new as well. To show you the idea behind this enable scale, I feel like I'm gonna use another example real quick, just so that you understand the idea behind that. I have this context right here where I have a simple grid, right, with some arrows. So we have a grid, can customize the amount of rows and columns. And what we have in here is an object in the shape of an arrow, right? So I have these arrow objects. And what I'm doing in the transform is that I'm using this enable step in the rotation to actually control at which angle I want everything to rotate. So let's reduce the scale a little bit. You can see that without it, everything get a random direction, in that case between 0 to 360 degree in Y. As soon as you use enable step, I can control what's the angle, like step in between those random direction. If I want 45, well, you start to have different kind of orientation based on 45 degree. So in that way, that can be very useful to scatter some buildings in a city, or anything that looks very graphic like that. You can get some pretty interesting results, right? So that's why I actually implemented this feature, and it's also available in the translate. So if I want to basically have a different step, I don't know, of 100, and basically say I want a step between 0 and 100, you can totally do that. So yeah, that's one thing to keep in mind. You can use enable step in some situation that can be useful. I'm gonna reset that real quick. And we said 90 degree in rotation step. So one thing too I didn't talk about is that you can actually use the points of an input. You see that I'm using the grid to scatter my my arrows, right? It's because I'm using this feature, use surface points as scatter. So without it, I'm actually reusing just like this kind of control right here. And yeah, that's not great, right? So that's why I'd rather use the surface point as scatter. I'm gonna say no to that because it's not animated. And as soon as we are doing that, we can use a custom point cloud, which in this case is just using the point of my inputs. So that's pretty nifty. Also kind of addition. Before it was also available, but under a different name, and it was kind of hidden. So I thought it would be nicer to actually expose it up. And basically, if you are using something else like a aligned scatter, you can totally do your scattering using this kind of feature. I know a lot of you ask me about adding scatter points around constraint points. That's the kind of thing that you would benefit from scatter align, but you can totally like do your scattering in there. Let's say I want to reduce the coverage, and you are doing your things, right? And you can totally use this input as a way to control stuff. So in that case, you can see that I'm totally reusing these points to actually control my scatter. And that would still be compatible using any scattered kind of distribution. The only difference is that you wouldn't be able to add point, but only to remove. So let's say, what do we have? A noise. So on a noise kind of configuration, we see that we are basically removing some points in there. So right now, because we have the display surface, we are seeing the points, but well, basically it would look like that. So yeah, something to keep in mind, you can totally use your own scatter if you prefer and link any geometry or do any operation that you benefit from this, this node to create your own thing. So let's go back to our example right here. So I haven't talked much about the scattering thing because it was a recurring topic in my past tutorials about this tool. But yeah, there are some subtle changes in there, and let's recap for people who have never used this tool. So you have this enable height distribution, and the difference than before is that you can have a height that is relative or absolute, meaning that relative would be relative to the bounding box of an object. When it is absolute, it would be based on absolute values. So in that case, between 0 and 1, it will create this mask. Between 0 and, let's say, 100 or 150, it will start creating some kind of ramp, right? You can also use compute range, and it should basically create this mask based on the bounding box. So yeah, there is a bit of weird default in the high density, so make sure you have that in check. So yeah, that's a pretty nice way to actually work. And in that way, it's pretty useful when it comes to scattering trees on mountains, because trees are growing to a certain height. After a certain height, you would have a different type of vegetation, right? So you can totally use this max height to define a certain type of vegetation and then create another scatter system for a different type of vegetation. So in that way, it should very help you to keep things as procedural as possible. So yeah, that's the most important change when it comes to height distribution. You now have relative and absolute. In the past, we only have relative control, which wasn't great because as soon as you updated a model, well, you would be forced to retweak a bit the high density, etc. So yeah, that could have been a problem, right? Let's see, what else do we have? And of course, you can combine that distribution with others. You can totally use a slope one, etc. So the slope one in that case, well, we are using a sphere, so it should be pretty interesting. You can define if you want things to grow in phase pointing up. So let's say something like between 80 and 0 degree or 45 degree. So for this example, it's actually not great because it's kind of destroying a lot of our terrain, right? But on flatter surface, it's actually much more relevant example. So we'll see that later. As usual, we have noise distribution, and as you can see, we can control the distribution based on the noise. And I haven't talked about the way you can control scattering yet, because sure, we have the density control. As you can see, we can totally say, I want 100%, 50%. But we can also control individually the scale of the tree based on this noise pattern and say, what is white? I want the tree to grow 150%. If I want the one that are in the black, I want 80%, that kind of stuff. So in that way, it's actually very interesting to create some breakup. What I tend to do, you know, is to increase the density. And where it's more dense, I want to reduce the size to something like 70. And where it's less dense, so it's 100%, I want to give more normal size. And it should help create some nice breakups. So we can adjust the frequency if we want to actually see that. Might really depend on the scale of your scene. But yeah, let's probably play a bit more with this max density. So yeah, in that case, we see that in the black, we have less trees and they are much bigger than the ones that are in white. So yeah, that's pretty interesting. And you have this kind of control in all the distribution system. One thing I haven't talked about is also the ID control. So let's reset that to 100%. What this ID control would do would basically help you customize where you want some ID to show up. If I'm reducing that to 0, you see that we have more of those red tree, the first tree that we specified. So thanks to that, you can adjust the probability of things to show up in certain area. So to clarify that, I'm just gonna disable the probability system that we have here. As soon as I disable that, we clearly see that the ID that is in blue is on the top. Then we have a range of the greens, the yellow, and the red. So you kind of see what I'm doing in here thanks to this ID control. And yeah, you can of course mix that with some probability and you can kind of really customize where you want your ID to show up. So yeah, that's something that you may not want to use all the time. Most of the time, you know, I'm mostly playing with the probability. So yeah, ID controls, I tend to leave that to 100%. But yeah, just know that you can do it if you want. As I was saying, we also have some other distribution system like object. So object, I can totally use another object like a sphere. And yeah, okay, that's kind of a crazy scale. It's something like that. And let's move it like here. I think this should be interesting. So I can use any of this input to actually drive a new mask now. And there is some big changes in how this works. You see that now we have this big hole. It almost looks like a Pokeball now. That's kind of cool. And now you see that, well, you can obviously control from which input the object is coming, 2 or 3. And you also have some ways to control how you want this mask to appear. So distance based on the inside, or based on the outside, or based on the contact itself. So the contact, you will need to play with this radius. And anything that is in contact with this object would basically get some scatter. So yeah, that can be an interesting way to work as well. And if you leave that to distance inside, you are basically blurring the shape of the intersection, right? Compared to before, it's super sharp, and now it's getting much more blurry. So yeah, that's one thing to keep in mind. You can also use objects to control not only the density, but maybe if you need somehow to affect the scale of this section. So yeah, you can always do some changes on the fly like that and keep things procedural. So yeah, just something to keep in mind. And that's some of the distribution system. So reminder, I've been hiding some of them. You also can use a map. So I did some changes in there in the map, trying to simplify things, especially when it comes to using UDIMs. You can always visualize what you are using as a base. So that's not a great example. Can use some bacon strip. I mean, maybe a checkerboard, I don't know. Something like that. Maybe you kind of see that you can use a map as a way to control your distribution, right? If you don't have UV, you can turn this off and it will do a simple Y projection. In the case of the sphere, you see that it's stretching a lot, so that's why I actually added some UVs. And yeah, you can control the repetition, of course, of the tilings. You can rotate things, etc. Yeah, and now also if you need UDIMs, and let's say you have something called something like that. Well, in that case, I don't have any UDIMs, but basically if you use UDIM, it would basically update the path and add this UDIM tag just to make sure to import all the different UDIMs of your map. So yeah, in that case, when you uncheck, it will go back to 1001. So yeah, that's a subtle change. That's basically using some Python under the hood. So yeah, map distribution can be very helpful if you have some painted texture, etc. In addition, we have remove collision. So remove collision can be a pretty dangerous parameter because it's obviously very slow. I'm still working on it, so that's very experimental. But basically, you can detect the intersection between the different trees and try to basically get rid of the objects that are intersecting. Let's give it a try. I don't know. Let's try to enable that. By default, it's based on the bounding box of an object. It's supposed to be a bit faster, but well, let's see. And yeah, as you can see, it gets rid of all the intersection. We are not left with much trees though, aren't we? But yeah, at least it makes sure that there is no intersection. So that's a new feature that you can use at your own risk. I would say save before that and make sure you don't have like millions of objects scattered. It's really much more for foreground stuff if you have some things that require high precision. All right, so let's move on. Actually, I'm gonna disable that. I'm gonna increase that. So we also have cluster ID. So cluster ID is additional attribute that you can add. It's a vector that is called clusters in that case, and you can use it to generate an attribute based on a noise, a Voronoi, or a random. So yeah, very different kind of system. That's the Voronoi by default. Doesn't have much stuff, but something like that, you know, it can be interesting if you need to bring some material variation in shaders. So if I middle click, we see that we have this clusters attribute that I like to use in shading to kind of bring some material variations. This way, all your trees may have different brightness, different hue, different saturation, and it does help bring some realistic breakup in your scattering. So yeah, that's a feature I like to use. We'll see how we can actually use that in shader very soon. I will show you a bit later. Camera culling. So camera culling is basically culling points based on camera. So in here, I also did a lot of changes to make sure that this is much cleaner than before and run much more smoother than before. So we need just to provide a camera. Let's maybe create a camera that will call, I don't know, cam call or cam render. Usually you want to use your render cam, right? But in my case, my render cam is this whole thing, so it's not gonna call much. So let's bring this cam right in here, see if we get something interesting. Let's say I have a frame like that in a shot and I want to limit the scattering in this section. To do that, I'm gonna head back in here and I'm gonna feed this cam call. All right, so let's see what is happening. Ooh, look at that. We have basically get rid of all the points that were not visible in the frustum of the camera. So without width. So that's a way also to optimize kind of memory, and I feel like it's a good thing to keep in mind when you are working on a shot. And you can use the color padding if you need some extra room. Maybe there are some shadows that should be here, and if you remove too much trees, that might not react as expected. Same with back culling. You can basically reintegrate some of the trees that were here before just by using this back culling. So maybe for reflection purpose, maybe for shadow and reflection mostly. And yeah, I think that's pretty much it when it comes to cam culling. And motion, well, this is mostly if you want to attach your particle system to a moving geometry. So let's say we have the terrain that's, I don't know, rotating or doing something funky. Let's see. We could basically animate that and just do something like doll or frame, and it would start rotating, right? So what's happening with animated geometry is that at every frame, it would start receding stuff, which is not great. So it's kind of hard to see, but basically attach instance to surface should help you optimize that. Yeah, now everything should be much smoother and it's following the objects properly. So, you know what? I think I talked about everything I wanted to talk about, at least for the main features. So in here, what I did, I have a lot of trees with some breakups, some noise breakups. If I'm looking in the distribution, we have some noise, some attribute mask, and that's pretty much it, really. There's one thing that's different than before. If I'm changing, let's say, to a box, you can totally try to render that, let's say, out of the box, and it should work. So let's press escape, and now I'm thinking if I'm trying to render that, let's make sure we have that visible. We have maybe some water and render. So I have my Mantra render set up. I think if I'm pressing render, this should be fine. And yeah, as you can see, it's starting to render everything again. So that's pretty nice. Even though we are displaying box, it's rendering the high-res version, and that's what we want. There is a way though, that if you want to actually render the preview that you have in your viewport, you can totally use render preview. So in the preference, as soon as you hit that, it would basically start to render the box that you have. So sometimes it's helpful, mostly if you are using the custom mode. Let's say in here you have this custom geometry thing, right? Maybe it's faster to render and kind of give you an idea of your distribution, your scale. That's very helpful. In that case, I want to render the full res geometry. So I'm going to disable render preview in the preference. And we'll also add another layer of rock. So I will break down this one as well. So as you can see, I added some sort of rock layer to do some kind of beach, like a shore around the river, and it's pretty stylized, right? It doesn't feel realistic. The scale is, is way too big, right? But it's kind of interesting looking. And I want to show you how this is set up. So if we have a look in there, we basically have the terrain, and let's have a look at the viewport. We have the different instances, so I'll press enter to visualize my terrain again. And what I did is that I'm still reusing this mask that we have in the attribute one, and instead I remap it to have those rocks fall into this river. So that's as simple as that, really. And in the objects, I'm basically applying some Megascan that I imported, and I'm feeding different thing in there. I also retweak some of the scale to kind of make sure that some are not too small, well, this kind of stuff. And yeah, there's really no limit how you can use this tool. You probably don't want to mix, let's say, the rock with the trees under the same scatter, because that would be a bit too fiddly to control. And yeah, that's pretty much it. So as soon as we go back to the object level, we see that adding rocks is kind of challenging Houdini and turning things back to bounding box. If you don't want to see those bounding box, you can always hit D for display option. And in optimize, you can change the polygon limit. In that case, after 50 millions, it's turning everything into box. But I can totally say 100 million, and now everything is back to well, there's still a lot left, but while increasing the polygon limit might start challenging your graphic card, so really depend on your hardware. So I would rather go inside these assets and start doing some optimization like we did at the beginning of this video for the tree. So let's have a look. So for that guy, that should be pretty straightforward. We could basically just drop a poly reduce like that, and let's start decreasing. Oh yeah, something like 2%. That's more than enough. And we'll just also, instead of using poly reduce, you can of course load the different LOD from Megascan. So that's another option, of course. I'm gonna call that low res. Yep. And basically in the AdvancedScatter, we would go back in there. We would change this low res geo, right? So we would change that to low res. So yeah, as you can see, there is a significant kind of difference between the different mesh, between A, B, and C. So ideally, I would do that for all the other geometry. Now, if you just want to use nothing else but the point and actually use an instance context instead of geometry, it's totally doable. So you would basically use instance, and maybe for those rocks right here, I will just cut these nodes and put them into instance. All right, I moved those nodes into an instance context. Now, all I need to do is either to uncheck attach object to scatter, or just to right click, like press enter, right click, attach geometry. You turn this off, and basically you should only see the points now. And the way, if you still want to visualize something, you can totally say in instance tab, I want to see the full point instancing, and then you see the rocks. So that can have its benefits to do like that. So note that it's another way that you can render instance. So that seems to work. We can try fast point instancing. And that would work too. There is one last thing that I would need to show you, which would be how to use this node within Solaris. All right, before wrapping up, I just want to talk to you about this scene workflow real quick and the AL tools that are involved. In this case, we have AL AdvancedScatter and AL Fog. difference compared to before is that I am here working in the stage context, also known as Solaris, and I must flag some difference when it comes to instancing. One way to instance efficiently is to use what we call a prototype that is attached to an instancer. So I'm gonna go back in maybe this state over here. It's looking a bit different. Probably I'm gonna turn off the trees instancer for now. Yeah, and now we see that we kind of have a pretty nice preview actually of all the different elements. There are millions of kind of clovers, dead leaves and things like that that are scattered in there. So in that way, it seems like Solaris is running quite fine, as you can see. When it comes to instancing, part of it is using what we call prototypes in Solaris. So if I'm going on this node, what's happening in the scene graph, we see that we have some prototypes and different kind of trees. So yeah, that's basically what's happening in there. So it's really a bunch of trees put together and registered under a prototype. To do so, I am using a layout node. So actually layout node is supposed to be used to lay out stuff, right? But in this case, I'm only using it to register the prototypes that it is using. So it's kind of a trick that I found out by using the layout asset gallery and the layout lab. So in that way, it's pretty easy to kind of come up with different library of elements. And I will talk about that in other videos, how you can make your own library, right, of different USD. In this case, we have a section for the wood debris, a section for the trees, etc. And all come from this layout asset gallery. So yeah, that's kind of a fun stuff. Of course, there are different ways to create prototype, but in this case, I feel like the easiest for me was to use a layout lab. So, and then the way you actually call those prototypes is by using an instancer, and in the second input, you basically plug your layout. And in this case, I can specify the prototype path coming from the second input. And as soon as I'm doing that, I'm able to actually attach some geometry on my points. And we notice that it is the proxy version, of course, because they are so low res, I needed to optimize them to make sure that they would run smoothly in Solaris. And I can display if I want the high res in there just by saying I want to see the final render. So that's the more high res thing with the set dressing on the trees, etc. And the different leaves. So I actually don't need them for preview. So I usually tend to leave it off and just set that to preview. So I will show you in a tutorial how you can actually configure your USD to have a preview and a high res mode. Now, inside this instancer, that's where I'm doing my scattering, right? So we are ending up with a bunch of points and I'm doing different scattering. Let's say for the trees, I have one for the left side and one other nodes for the right side so that I can orient my trees like on each side of the road. And what I'm actually doing to assign some objects, well, you can see there is kind of nothing in here. So either you can use an attribute randomize to create an index attribute. So I'm using a custom discrete to assign a weight to the different index. It's basically how I created the probability system, right? So the value of 0 would be the first object of my prototype with a certain weight. Value 0 would be the birch A, value 1 would be the birch B, etc. You get the idea. So one way, if you don't want to use an attribute randomize, is that you can actually use the assign object, and this will basically correspond to an index. If I'm middle clicking, we see that we have an index that have been created. But yeah, basically this box doesn't matter anymore. You could say anything, Ras B. It doesn't matter as the lop instancer look for the index attribute. And what matters is the order of your prototypes and the probability that you are assigning to them. Yeah, let's have a look maybe at another objects like this grass right here. So I'm adding in here some little plants, right? So I'm gonna show all. So to see a bit more what's happening, I will just increase the size of those guys. And yeah, let's see. In the object right now, there's nothing, right? Because I'm already using an attribute randomize. And as soon as I disable it, it's based on the index that is provided by this node. And the index by default is 0. So as soon as we start adding objects, we are introducing more elements coming from the prototype. And now I start to see this plant geometry showing up. So probably I can reduce the probability of some of these guys to actually focus on having these kind of plants. Now I'm starting to see some yellow variants, etc. It's not the most straightforward, but everything in this case is based on the order of your prototypes that you have in here. So in that case, 0, 1, 2, 3, 4, 5, 6, 7. So maybe I will come up with a way to assign things a little bit better in Solaris. But in the meantime, this is an option that you can use. So one other aspect I want to talk to you about is fog. And fog in Houdini, I always feel has always been kind of a tricky thing to deal with. So what I'm doing here is that I'm basically creating a volume based on the camera frustum. And to do that, well, I first need to use the subcontext. So let's see what we have, fog A. And if I dive in there, so this brand new AL fog that has been added to the package of the AL tools is basically a kind of convenient way to come up with some fog. And you can basically adjust the distance, how things fade, etc. if you want like your fog to start a bit earlier or fade much more quickly, etc. So yeah, that's kind of handy in this way. And you also have some control in the max height. So if you want to limit the fog height to a certain degree, well, you totally can. So that's been pretty useful in my case because I love to use fog and there is no out-of-the-box solution within Solaris or Mantra. At this point, we covered most of the latest updates. You also have the Ultimate Terrain Workflow series that I did a while ago that covers most of the other tools that I actually didn't change much since, apart some fixes here and there, but yeah, pretty much it. So yeah, that was a pretty long video. Hopefully you find answer to all your questions. If you have any feedback, anything you want to share, ask me. I'm always happy to improve the tools, obviously. Now I'm gonna clarify a few things in terms of licensing. So if you have been buying my project on ArtStation or Gumroad, well, you can have the update of the version 6 for free if you bought one of these projects. So if you are considering buying one of these items, note though that those are only available for Houdini Indie or Houdini Apprentice, because the way licensing works, since I'm using Houdini Indie on my machine, it's not compatible in Houdini FX, and that's something I understood way too late. Now, I've been suggested to use Orble to upload the tools, and so I did. So you have now a full commercial license, Houdini FX, and a studio license available if you are part of a bigger structure. And while you're at it, check out Orble's website because there are some very cool tools created by the Houdini community. So a lot are for free actually, so that's totally worth checking out. And that's it for today. Thanks so much for watching this video. Take care, and I'll see you guys in the next one. Bisous bisous.